This one is Geometry, Semester 2. It's the unit on Angles Review. It's Unit 8, and it's lesson number 4 in that unit, Angles Review, and it's parallel lines cut by a transversal practice. It's on creatormath.com. You might have to type in creatormath.weebly.com into Google to find it. It's under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. We look up the notes on other videos. I'm going to skip it this time and go straight to the review problems from creatormath.com. Yes. Okay, so what do we have here? It says, given the following diagram, angles 1 and 4 are called. So here's angle 1, here's angle 4. But let's look at what we're given. It should, because this is a review lesson, this should look very quickly familiar to you, I'm hoping. This line here and this line here have arrows on them. What do those hashtag arrow marks tell us? It tells us that these two lines are parallel. Parallel means they lie in the same plane and they never touch or cross. That means they are the same distance away from each other all the way down forever in both directions. Then this line across it is called a transversal. It cuts across and it creates for us 1, 2, 3, 4, 5, 6, 7, 8 angles that we find wonderful as geometry teachers. Why? Because the angles have one of two relationships. Either they are equal or they are supplementary. Okay, not all my writing skills are bad, spelling skills, all that. I apologize, you guys. Supplementary. 2 P's, I believe, are in supplementary, I hope. So supplementary means they sum to 180 degrees. Right? So that's it. You either have this, equal, or supplementary. So these are vertical angles, 1 and 4, and that means they're equal. So all we have to do is come down here and say vertical angles, they are equal. And remember, vertical angles back from those lessons, right? This is review, but let's just cover it really quickly. Vertical angles do not have to be vertical up and down from each other. What it really means is across from each other, and I always say I would rather in geometry vertical angles have their name changed to across from each other angles. For example, 2 and 3 are across from each other. They're equal. And if you took a piece of paper and traced through it and then rotated around and traced through it, you would see that they exactly lined up. So let's keep going. Given the following diagram, angles 2 and 3, so these two angles, 3 and 2, they are vertical angles, they are equal. And remember, my answer is always the first one, but on your problem sets, they're going to be randomized. So look for the right one. Vertical angles does not necessarily mean vertical. It means across from each other, and they are equal. Given the following diagram, angles 5 and 8. Here we go. Looks like we're going to do all vertical. Right? Those are vertical, they are equal, and because they are across from each other. So if I draw any x here, this angle and this angle are across from each other, they're vertical, they're equal. And I know they're up and down, so that kind of tells students, hey, vertical means up and down. But no, this angle here, here and here, these are also equal to each other, and they're not up and down, but they're also called vertical angles. Hence the trouble with a lot of these math problems, right? The language is challenging sometimes. So, okay, given the following, how about 6 and 7? 6 and 7 are across from each other vertical, they are equal. And that means if you told me a number for, an angle measure for 6, I would know exactly what 7 was. What's 3 and 6? Here's 3, here's 6. So these are inside the parallel line, so they're called interior. And they're on different sides of the transversal, so they're called alternate. This is alternate interior angles, and they are equal. 4 and 5. 4 and 5. Again, they're inside the two parallel lines, so they're interior. They're on opposite sides of the transversal, so they're alternate. Alternate interior angles are equal. And so far, we said there'd be two relationships, right? Equal and supplementary. We haven't hit a supplementary yet. These have all been equal so far. 1 and 8. So 1 and 8. They're on the outside of the parallel lines. One on top, one on the bottom. Outside, so exterior. And they're on opposite sides of the transversal. So it's called alternate exterior angles, and they are equal also. 2 and 7. They're exterior and they're alternate, so alternate exterior angles, and they are equal. 3 and 5. Here's 3, here's 5. Now, here's where things start to shift a little. These are interior because they're on the inside, but look, they're on the same side of this transversal. So these are called same side interior angles. Now, these have a relationship of supplementary. So if you notice, look at how this one's obtuse, and look at how this one's acute. That may tell you right off the bat, hey, they look like they match up, but also 5 can be moved up to 1. 1 and 5 are corresponding, they're equal. So they're on a 180-degree line here. So these are supplementary, which means they sum. Sum means add. If you took 3 and 5, 3 plus 5, and we might use an angle symbol here, angle 3 plus angle 5 equals 180 degrees. That's what this means, sum to 180, and that's what the word supplementary means. 4 and 6, they're same side interior, and so they are supplementary. Same side interior, and they are also supplementary. Let's put it this way. If you look at 4 and it's an acute angle, and you look at 6 and it's an obtuse, at least you know they're not equal, right? Visually, I can tell these are not equal. And if they're not equal, and it's this relationship of two parallel lines cut by a transversal, that means they're supplementary. It's either one or the other. And if you look at it visually and they're not equal, right? They don't look equal, then they got to be supplementary. 1 and 7. So here's 1, here's 7. Those are called same side exterior. Same side exterior angles, they are supplementary. Look, they don't look the same, right? Guess what? Supplementary. They sum to 180 degrees. So how about angles 2 and 8? Here's 2, and here's 8. Those are same side exterior. Same side exterior don't look the same. That means they're supplementary. So the strange thing about these series of angles with two parallel lines cut by a transversal is at first they look daunting, but once you start to get the hang of this, I'm going to tell you. So 1 and 5. These are called corresponding. Corresponding means they share the same location. And I wonder if I can even show you this on the video. Look, here's a sticky. Can you see through this? Here's the one angle. Let's draw it, right? Here, this angle here, that's angle 1. Now, let's pick it up, slide it down so that it's right on top of this. And I wish I had actually a piece of tissue paper would be better. But notice how this angle is exactly the same. They are equal. And those are called corresponding angles because they share this location on these two separate parts. All right, hope that helps, but these are corresponding, they are equal. I have a feeling we're going to do a bunch of corresponding here. 3 and 7. 3, 7. Corresponding because they're both in this location, and if I did that same paper trick of tracing through it, you would see that same thing match up and be, exactly the same as long as I could draw it right? I'm just drawing freehand. 2 and 6. 2 and 6 are corresponding locations. That corresponds to that location. If you picked this up and superimposed it upon it, they would be in the same position. They are equal. Corresponding angles do not have to be equal, but in the situation of two parallel lines cut by a transversal, they always are. 4 and 8. Corresponding locations, they're equal. Number 17. All right, here's now the first problem we have. Given the following diagram, if angle 3 is 108, so this equals 108 degrees right here. What is angle 6? Where's 6? 6 is over here. Well, these are on alternate sides, and they're on the interior. We already said alternate interior are equal. Even look at it. This is an obtuse. This is an obtuse. If this is two parallel lines cut by transversal, if they look the same, they are. So 6 has got to be 108 also. Man, it looks so hard, but then when you finally see the answer, you're like, well, that's pretty straightforward. So what else we got? Given the following, if angle 2 is 120 degrees, so let's say this is 120. What's angle 7? So angle 7 is way down here. These are alternate exterior angles, right? Alternate exterior, we already said were equal. So if this is 120, angle 7's got to be 120 right here. There you go. Only two relationships. Either they're equal or they're supplementary. As long as we're dealing with two parallel lines cut by a transversal. And all of these problems are, that's the point of this lesson, is to drive this home. So if angle 3 is, this equals 120, and it says what's angle 5? Now, these are same side interior, which are supplementary. So now I have to say 120 plus 5 equals 180. What would I have to add to 120? And this should be angle 5. Thank you. That makes it a little bit better, so we know it's a variable, not an actual number of 5 degrees, but an angle 5. So this has to be 60 degrees to add up to 180. This has got to be a 60-degree angle. And one last one right here. Given the following diagram, what is the line called that cuts across the two parallel lines? What's this line called right here? It's called a transversal. Trans means across, and basically speaking, versal means a line. I mean, that's a basic translation, all right? But trans means across. This one cuts across the two parallel lines. So this is review of angles. So this is angles. Here it is, Geometry Semester 2. It's unit number 8, angles review, which means we covered it in prior unit, right? And this is lesson number 4, parallel lines cut by a transversal practice. It's on creatormath.com under the geometry tab.